where K is a constant of proportionality, constant, which will be called, and depends on the material, how the stiff, stiff is the spring. So the stiffness constant or spring constant. If the spring is very strong, K will be higher. If it's very weak, K will be lower. So, which is called the stiffness constant or a spring constant or force constant, the three names. So the force constant K will be given in Newton over meter, and that tells you how stiff is the spring, Newton over meter. When it's linearly, the spring will be called ideal. So ideal spring is the spring that obeys the Hooke's law. Okay, so knowing that, this is the force. Now, let's find if the force, if the work done by this force is conservative or non-conservative. So, by definition, if I get the work done by this force from initial and final position, how can I get the work? What is the definition of work? Let's go to a definition of work. I want to find the work. What do we do? This is work. What will be? The integral of my force. Since my force is not constant, I cannot use this rule. I will use this, the general one. So it will be the integral of negative kx dx. What will be the work? From x initial to x final. What will be the work negative? What is the integral of kx? K is a constant. Negative kx squared over 2. From x initial to x final. So the work will be negative k over 2 x final squared minus x initial squared. Is that right? That's the integral? So from here, what can we say about this work? The work done by the spring is conservative or non-conservative? Depends on a constant, on the final and initial position only. Is conservative or non-conservative? It's conservative. So this is the second conservative force. We know the work done by the spring. So the spring force, which is this negative kx for an ideal spring, is conservative. How can we find now the change in potential energy of the spring? What will be? If this is the work done by the conservative force, according to the definition, what did we say? That always delta U will be opposite, right, to the work done by the conservative force, opposite. So what will be delta U of the spring? Now, can you see that if x initial and x final are the same, x initial and x final, there won't be work done. The work will be 0. So it's conservative. Now, this is the change in potential energy associated. You know that if there is a conservative force, always there will be a force associated with that conservative force. This is the potential energy of the spring, which you use the same formula, this formula, to find it. So since we know that Hooke said that the force is negative kx, I just put this into this, and I found the change in potential energy for the spring. This is a new formula. Now, what can I say about this? U of the spring. At 0, at the point of equilibrium, this is called point of equilibrium, when there is no extension of the spring. So if I graph potential energy versus x, how will look the graph? K over 2 x squared, right? At 0, what will be the potential energy? At 0, if it's K over 2 x squared, right, at point of equilibrium. So at 0, what do you think that will be the potential energy? 0. So at the point of equilibrium will be 0. So it means that u with respect to 0 will be k over 2 what? X squared. This will be just the definition of potential energy of the spring. Potential energy gravitational with respect to 0. What will be the formula? Potential energy gravitational with respect to 0. What will be the formula? What is the formula for potential energy gravitational? mg delta y. But if y initial is 0, what will be the formula for potential energy gravitational? mgy with respect to 0. That's the only thing that we can say potential energy at a point, because have to be between 2 points. But if you say potential energy at a point, have to be with respect to the 0 configuration. Otherwise, doesn't have meaning. So mgy, or sometimes you will see mgh. Have you seen that before? mgh, that's potential energy gravitational. This is the mgy we are talking about. This is with respect to 0 at any point. So at the point of equilibrium, what is the potential energy? 0. At the maximum point, if it's k over 2x squared, and you graph the potential energy versus x, how will look the graph? A parabola. Right? So imagine that I put this spring here,